So question number 10, it says a sector AOB of a circle center O has radius so and so. Given that the area of the sector is 6 centimeter square and that the perimeter is 10 centimeter, show that 3 theta square minus 13 theta plus 12 is equals to 0. Okay, let's see all the information that we can put to use. So we're given the area. Now area, as we know, is equal to half r square theta. Okay, now there are two formulas. One is half rs, but that doesn't have theta in it, so I'm not going to use that formula. Instead, I'm going to use half r square theta. And what's this equal to? This is equal to 6. And the perimeter of a sector means the 2 radii plus the arc length, which is equal to r theta, and that's equal to 10. Okay, so let's put this together. This is the first, let's substitute them. But first, let's make r the subject using any one of the two equations. I think I'm going to go with equation number 2 because it's relatively easier making r the subject in equation number 2. So first of all, this would be equal to r square theta is equals to 12 after cross multiplying. Okay, so this rather is the first equation. Okay, and also this is not the first equation, and in fact, let me simplify, and then I'm going to call it the second equation. So r plus r will be 2r plus r theta is equals to 10. Now this is the second equation, and from the second equation, I will take r common, so that would be 2 plus theta is equals to 10. So that means r is equals to 10 upon 2 plus theta. Now I'm going to substitute this into the first equation. So that means 10 upon 2 plus theta. Don't forget the whole thing square, and also don't forget to multiply it by theta, is equal to what? Is equals to 12. Okay, now 10 square is going to be 100. As far as 2 plus theta, the whole thing square is concerned, we have to use the identity. So that's going to be 4 plus 4 theta plus theta squared. Don't forget that there was a theta here from before, is equals to 12. Okay, so now we're looking at 100 theta is equal to, in fact, let's cross multiply. So 4 times 12, that's 48, plus 4 times 12 again, that's 48, but this time with theta, plus 12 theta square. Now let's move all the terms to the left hand side and see what do we end up with. So we end up with 12 theta, actually let's move all the terms to the right hand side, yeah. So 12 theta square, we leave that as it is, okay. 48 minus 100, so that's going to be minus 52, yep, that's correct, and plus 48 as it is. Now this doesn't match with the equation that we're given, but that doesn't mean we've done something. That doesn't necessarily mean that we've done something wrong. All we have to do is divide it by an appropriate value, which in this case is 4. So divide both sides by 4. Obviously, the right side, it will not make a difference to the right hand side, but the left hand side becomes 3 theta square minus 13 theta plus 12, exactly what it's supposed to be equal to. And this is what we were supposed to prove, and we have thankfully done just that. So proved. Let's write that down. Make sure to write this conclusive statement. Okay, the examiner is looking for it. Now, that was the answer to part A. Let's have a look at part B. Hence, find the possible values of r and theta. Okay, so now it's just a regular quadratic equation. So 3 theta square plus, sorry, not plus, actually minus 13 theta plus 12 equals 0. Now we can do middle term breaking. Yeah, how about that? Let's do middle term breaking. So 3 theta square minus, so factors of, okay, middle term breaking, is that possible? 12 times 3 is 36. Yep, 3 and, no, wait a minute, 4 and 9. So minus 4 theta minus 9 theta plus 12 equals to 0. Let's take theta common. So we have 3 theta minus 4. Let's take minus 3 common. So once again, we have 3 theta minus 4 is equals to 0. So that means one possible value of theta. I will continue from here. So theta minus 3 and 3 theta minus 4 is equals to 0. So that means one possible value of theta is 3, or the other possible value is 4 upon 3. Okay, now let's refer to the question and see what the question says. Find the possible values of r and theta. Okay, so there is nothing in the question which suggests that we're only supposed to take one value of theta. So I think we should take both the values. So let's write down let's find out the corresponding values of r. So when theta is equals to 3, remember r was equal to 10 over 2 plus theta, if I remember correctly. Yep, so 2 plus 3, so that means r is equals to 5. Okay, so let's write this nicely. Theta is equals to 3, r is equals to 5, and when theta is equals to 4 upon 3. Let's see what r is equals to. R is equals to 10 upon 2 plus 4 upon 3. So 4 upon 3 plus 2, that's going to be 3 times 2, that's 6. 6 plus 4 is 10, so 10 upon 3. So I think it would just be equal to 3. So 10 upon 3, yeah, so 10 divided by 10 upon 3 basically means that r is equals to 3. So once again, let's write it nicely, that when theta is equals to 4 upon 3, r is equals to 3. And there you go. These two are basically your final answers.